Good evening, everyone. Day 2 of our class, and I just remembered, Anil, can you hand this to the gentleman in the green shirt back there? And I think Robert has a pen that he can use to speak. Robert, do you mind giving that big pen to the guy behind you? Thanks. Hopefully everyone remembered to bring their name tent. I'm not that quick to learn your names in one day, and there are a lot of other people in this class that hopefully if we're having a discussion, you can say, as Taylor said earlier, or Caitlin, you can refer to people as a name. We kind of feel like it's more of a community here, that we're not just students that sit in a big room, but that we're learning from each other. To start off with classes, the way I always try to do this is I want to set the tone that we're here to be productive and work and to learn. So I'll always put up the first question of class, and I'll open it up as soon as I get here. So this question's been up for half an hour. If you get here, kind of think, okay, what were we doing before, or what was the pre-class quiz? And then you can start working on it. You can ask me questions as I'm walking around, or you can ask me other questions. I usually come at least 15 minutes before class, if not 30, or today it was maybe 40 minutes. So just know that that's an option if you are able to come before class. I also do stay a few minutes after class a lot, if people have questions. So if you have a burning question, you know that there's 15 minutes between here and lab if you have lab right afterwards, so you can stay for a few minutes and ask a question. If you aren't able to catch a question, then office hours, and I'll talk about that in a second based off the polling we have. So let's just get started right away with dimensional analysis. I only have 21 responses, so make sure if you don't already have your iClicker out and running that you pull that out. And then I want us to think about how to use the dimensional analysis approach that we had for our pre-class quiz in order to solve this. I know that we could probably just do this mentally and do proportions, but what should it look like if we do dimensional analysis? And we'll really carefully lay out those steps. So turn and talk to the person beside you or the people beside you. See if they have written it out with dimensional analysis, how they use these equalities, this equals that, this equals that. How do they use those things in order to write out the solution to this problem? I'm focused on the process and less about the numeric answer. All right, so go ahead and take 1 or 2 minutes. Check with the people around you, see if you had a similar process, and then we'll come back together and we'll hear how that might have been set up.
I forgot to do
All right, let's do two things. The first, how many people are not able to join iClicker because it says you're not here in the right location? Okay, so what I'm going to try doing is I'm going to try to turn off the location services. Shoot, I might have to do that. Okay, so go ahead and join the class now. Is anyone not able to join now? Raise your hand if you need another second. All right, and I'm going to turn it back on. So I think that's our way of kind of turn on. There we go. I think that's the way we kind of have to do it. It's kind of a pain, and I hate doing it. Anyway, for now we'll do that. So then let's talk about the approach to how we set this up. And I want us thinking about dimensional analysis when we do this, and not just can we get an answer. So can I have a volunteer to describe what's the very first thing you do when we get some sort of problem and it's kind of in gibberish? It's on purpose that it's like symbols and not specific units. What's the first step that we would do? Yeah, Tay?
The first thing we did was set up what we already knew about the equation.
Okay, and what do you mean by what we already know about the equation?
So 5 squared over 1 triangle was the first part of it.
So I might even do one step before we start to set up what the conversion factors are. So what Taylor was saying is that we know that because these two things equal each other, we now have a conversion factor that if we know how many squares we have, we can convert that to triangles. If we know how many triangles we have, we can convert that to squares. Okay, there's a step before that I'd like us to do. Yes?
We have to figure out what we're looking for.
What are we looking for? So what did you decide we're looking for in this problem?
We're looking for how many circles and 30 squares.
Okay, so the two things I'm going to refer to that as, what is our starting quantity? You always want to identify the starting quantity. That's super important. And then on the other end, you're going to say, what are we trying to get to in the end? So those are, I call them bookends, because it's what we start with, what we're ending with, and if we know what those two things are, then it allows us to say, well, what do we have that will help us get from here to here? So then we're going to do, I kind of wish that I had a whole bunch of empty space. What I'm going to do is, all right, I'm going to maybe need those numbers read back to me in a minute, but so our starting quantity we said was 30 squares. What are we going to do with that equation-wise when we figure out what we're starting with? I always want to see it over 1 as the top of a fraction. If our starting quantity has multiple units, then that might be a little more complicated. And then the far end, we're going to say equals. What's the unit we're trying to get to? All right, and I realize that this is a terrible symbol because it looks like a 0. That was pointed out to me last class. I suck. All right, so that kind of sets us up. So we know that somehow we're going to need to say, well, I know I have so many of these square things. What can I convert directly from squares to circles? Do I have a conversion factor that allows me to do that? If I do, great. We're just going to use that. We're done. But in this case, we don't. So then we look at what Taylor said. Do we have any conversion factors at all? And if we do have conversion factors, how are we going to start using them? So what is the first conversion factor that you found that looks like it would be useful here?
5 squares equals 1 triangle.
So Stephanie, say it again.
5 squares equals 1 triangle.
So we have 5 squares is equal to 1 triangle. So that gives us 2 conversion factors. 5 squares over 1 triangle is 1 conversion factor, or a triangle over 5 squares. Either one of those are completely fine to use because they're not going to change the quantity of what we have. They're just going to change the unit we describe it in. We'll come back to that in a little bit. So which one of those would be most useful here to convert our squares into another unit that might get us to where we want? Can I get a hands raised so we're kind of moving along? And I can't see your name, 10, sorry. Rachel?
Yeah. 1 triangle over the 5 square.
1 triangle is the same as 5 squares. So if I put this first part in the sentence, I would say that we're converting squares into triangles because we know that every 5 squares is one triangle. I'm going to spend a lot of time this semester talking about what it actually means as a sentence form. So if we did this calculation right now and we stopped, what would we have? I get a hand raise? Ryan?
30 triangles over 5.
Because we would be able to cancel out these units. And then we could simplify that to
6 triangles over 1.
okay. But that doesn't get us the answer that we need, right? So that would not be an appropriate place to stop. A lot of us are tempted from previous classes to do one step at a time, and then we take that answer, and now we do another step, and I take that answer, do another step. I don't want you to do that at all. On exam 1, I will have a short answer part, and you will have to show me that you can do everything in one long calculation. So I'm going to backtrack here, and instead of doing equals, I want you to have in your head, if I stopped my calculation, what unit do I have now? So we just showed the calculations, that's a triangle. But how do we get from triangles? Is there a way we can get from triangles? Do we have another equality we can use to get conversion factors that get us there? So what are the other equality? What's the other equality we have? Hand raised? There?
Stars. I put 3 stars over 2 triangles.
So this is the equality. 3 stars equals 2 triangles, which means we can have 3 stars over 2 triangles as a conversion factor, or 2 triangles over 3 stars. And so the first one we used was this. Which one of those 2 are we going to use now, Tara?
The stars over triangles,
Why?
so that the triangles will cancel out.
Because we want to convert away from triangles, because we've already converted squares. So then we do, which then allows us to convert between those units. Great. If we stopped right now, what unit will we have? Is that what we want?
No.
Okay, so what do we do? Andrew, what would we do next to try to get closer to the unit that we want? Mind me picking on you? You can pass if you want.
Yeah, I'm not really.
Okay. Kisa, you want to follow it up?
Oh, I just have a question.
Okay.
Because 3 stars is the same thing as 1 circle, why wouldn't you just put 1 circle over 2 triangles? Like, it just seems like a little extra.
So this is something that we can be very tempted to do, is we can take 2 conversion factors and merge them together, and it seems like we're saving time. But I don't want you to do that. I don't want you to merge together 2 conversion factors, because what you're doing in essence is you're shortcutting it. And the whole point of doing this is that you can see the entire process and make sure you didn't make any small mistakes. And so if one of your steps is combining things, then using that combined function, then it ends up potentially costing you in the long run. So for now, show me everything in unit conversions. So what is the final, I think you said it was, what's the final conversion factors? 3 is 1 circle. Terrible unit. Right? So if that's the equality, we can use it either fraction. And which one is appropriate? Are we going to have circles on the top or circles on the bottom? So we have circle over 3 stars. And once again, we look at our units, make sure that they're lined up properly. If we don't have them on the top and the bottom, mathematically they don't cancel out, if we remember our fraction rules. So then it's useless. We end up, if we have stars and stars on top, we have stars squared, which doesn't make any sense. None of this makes sense, but mathematically that's no bueno. So then, if we stop here, what units do we have? Which is what we were trying to get to, right? So by having that bookend over there, we know that that's the unit we were trying to get to, and we can stop. So, are we done? How do we get to the end? Let's multiply across the top. So on the top we have 90, and the only unit left is circles. On the bottom we have 10 times 3, so we have 30, which isn't quite what we wanted. So we can simplify down. 3 circles over 1. Did everyone everyone submit that as your answer in the clicker?
Yes.
Okay, well you can submit your response up until I close it. So if you wanted to submit that answer, you could do that now. Just kind of getting used to how clickers work is really the reason. And to make sure that whenever you have an open response like this in clickers, you put in your value and then you hit the send button. If you don't hit send, it doesn't automatically receive it, because what if you wanted 30 and you put 3, it thinks you're not done yet. Question?
Okay, so does it have to be with open or can it just be 3? Because I put 3.
If you're writing it out, I want to see 3 circles over 1. But if you're submitting your answer, the appropriate answer of how many circles is 3. Does that make sense? So after class, Ryan and I were working on this problem with Jay, and Ryan did something really cool at the end of this calculation. Can you tell us what you did and why? Do you remember what I'm talking about?
Sorry.
So you related these two things together. Remember? Okay. We just created a new equality. What's a new equality we created? Or you could say 10 squares equals 1 circle. This is something we're going to use throughout the semester as well. It's thinking about not only doing a whole bunch of calculations and getting it to line up properly. This is the mechanics, right? That's why we're focusing on stars and triangles and other things. But in the end, you want to be able to put together sentences. For every 10 squares, I have 1 circle. We're going to do a few more of these, and hopefully after seeing the process, you're going to feel comfortable doing this. As we go forward today and in the class, at least until exam 1, I want to see on your paper you writing it out every time, like this in long fashion, and avoid the temptation to just do it in proportions and to do 1 step at a time, because you will make more mistakes that way, I promise you. And then I won't be able to see what you did as easily, and so it's very difficult for us to grade that on exams and make sure that you're following the process. Once you've used this for a while, if you still despise it halfway through the semester, we're going to be more lenient on letting you choose the approach you want, but I want to make sure that you know exactly how to do this so that you can choose that later on. Any questions on the approach that we did so far? Do you feel like you could do this on your own? All right, let's practice in a second here. Before we do that, I do have some announcements, and actually I'm going to close this out. And I'm going to show... So the final result, so this is what it looks like when I can put up answers if you haven't had clickers in class before. Usually I won't show the answers. I'll use them for my own knowledge to understand how best to move forward with everyone. But this is one of the powers of having a classroom, which you're doing, and I actually see the results. So this is the game plan moving forward. In today's class, the reason that you're all here is that by the end of class, I want you to be able to identify conversion factors and apply them in order to make sentences or to do mathematical conversions. And then kind of more high level, I want you to be able to state that written relationship verbally and to be able to talk about what that relationship actually looks like and what it means and why we're using it. So we're going to get beyond shapes. We're going to be using units today, and I want you to be able to kind of use that in a more effective manner. Logistics. I did send out a poll, and I had 23 respondents, so I know it wasn't a majority of the class, but it's difficult to get responses sometimes. But based off of that, a large majority of our students could meet before this class on Wednesday. There were about 6 students who weren't available during that time, but a number of them were available Friday during that second time slot. So for now, these are going to be our office hours. Depending on how attendance goes at these, we may flex or move them. I know that during the semester there's 2 weeks where I won't be here on Fridays, so that will play a role. I have these posted on Blackboard as well, so if you're ever curious or going to go to office hours, please check there to make sure you know the location. Science Lab 273, do we know where that is? So the building, the floor you had, or have lab, in is just across the way here, 2nd floor. Lab is in this corner, closest to us. My office is in kind of the back corner, in the middle section. So it's a little closet, kind of looking office. It's fantastic. And then I also am fortunate enough to be part of the STEM Education Center on campus, which does outreach for K through 12 and some other things. And that's in ETAS, which if you were just to fly through this wall right here, it's that building right behind us. And my office is the closest office to this location here. It's this front corner of the building. So you walk in ETAS, the main doors, and on your left you'll see these really cool looking doors that say STEM Education Center, and they're kind of like art on them. You can walk in there. My office is back in that suite. So those are the 2 locations for now. I have had a number of students using this, and I greatly appreciate it. There are a lot of growing pains of getting used to all the online platforms we have, how to utilize them, when to be where. So if it's a question that you think another student in class might have, and it's not like your personal information, like, hey, I have a doctor's appointment at this time, don't post that, right? Send me that in an email. But if it's a question that other people might have, you see a homework connection issue, or someone said that there's one of the problems showed up as gibberish, and that's a problem that might be widespread. It might be a system error. So go ahead onto Blackboard and post that in the discussions. And I'll show that really briefly, where that looks like. So now your home page, if I enter the student view, is this page here. So the link to Blackboard discussions is just one of the first things that you see. If you click on that, you can, if you have a logistics question, like the homework platform is not working, post that there. Or if you have questions about concepts, or you have suggestions. So after last class, Eleanor posted a video about how to do dimensional analysis, and it's done by a nurse. And so if you have resources you want to post, do it there. If you have things you want to learn, you can go there and see if others have resources. You can post a question there and say, hey, I'm really struggling on this concept. Here's the question. You can put it up, or you can ask this type of question, who has resources. I'm subscribed, so you can hit the subscribe button right here, and then whenever someone posts in here, it'll email you a notification. I'm subscribed to everything in my class, so I will get the notifications and I will reply as soon as I'm at a computer. But there might be students in the class, so some of these were actually answered by students before I had a chance to answer them. So just know that that's a really good resource for us. Let's see what else we have in announcements. Almost half of you have found the syllabus quiz, which is kind of cool, because I don't even know if I mentioned it on Monday. Most of your classes, I don't know, my classes at least, where the first day was all about the syllabus. Y'all can read. I don't need to read that to you, so that's why we spend the time talking about what our class is going to be like instead of all the technical details. So make sure to go into the Blackboard and find the syllabus quiz. It's in the same place as your homework is. Download the Word document, do Control-F, find what you need in the syllabus, and then just go ahead and take it. 16 questions. If you submit it and you get some questions wrong, it'll show you what you got wrong, what the right answer is. Just go back and take it. I just want you to know that the first response shouldn't be to email me if you have a question that's probably in the syllabus. All right, so just trying to make things a little bit smoother. I noticed a lot of people on iClicker had signed up, and under their student ID, a lot of people put their T number, but some people didn't. So please put your T number in there. Because that will also allow me to sync your grade from iClicker into Blackboard. So if you can go back and check your profile in iClicker, make sure your T number is there, that would be great. I had some questions, some confusion, just because it's the second day of class. Our online homework, remember there's 3 components. Before every single class, the entire semester, there will be a pre-class quiz. It's due at 5:30. Today is the only pre-class quiz that has a possibility to be turned in late. Any ideas why I normally don't allow those to be late? Philosophically, why would I not allow those to be turned in late? Pre-class quiz, and what's the purpose of it? You have to know that coming into class, or else we're going to waste everyone's time. So if half the class has done the reading or caught up on the content, the other half hasn't, we're not going to be able to do the activities, and it's going to be a waste of our time. So there will not be opportunities for doing that late. If you miss class because of an illness or something like that, let me know and I can do an extension if you weren't in class, right? It's a different scenario, but if you come to class, then that's the expectation. Taylor, do you have a question?
Yeah, are the pre-class quizzes, are they graded on participation, or are those the actual grades for it?
It's graded on getting it right, but you have 3 attempts to get that right. So remember, the first time, take it to see, do I already know this concept? If I do, 100%, and then you're done.
Okay.
If you take it, you don't know what you're doing, then you know where to go study. Come back and you have 2 more attempts. Whatever your final grade is, the highest grade will count. Homework, same thing. You have unlimited attempts, I think, at most of the questions, except for the multiple choice. So go ahead and just keep working on that. check yourself, make sure if you're taking 7 attempts to answer a question that you realize that's a red flag. Maybe I don't know this, and even if I get it right after 7 attempts, I really don't know it, so I need to learn that. This is 1 attempt and done. It's timed. We'll have our first one open Saturday morning, closes Monday night. 1 attempt, you have 25 minutes to complete it. There's, I think, 3 questions. It should be very doable in that amount of time. Make sure you have a solid internet connection. Make sure it's the same device you've used to get on your homework, because if it's flash-based and you're using an iPhone, it might not be compatible. So please make sure that you've tested your device, you've tested your internet connection. Once you log in, that 25 minutes starts on the server. You can jump between devices, that's fine, but you can't come back an hour later and finish it. It does not work.
It opens on Saturday, so.
Open Saturday morning as of right now. I'm willing to consider changing that if someone has concerns about
That would be wonderful.
Saturday morning to Monday night. It's open all the way until Monday night at midnight, so think about whether the time frame will work or not. Alright, I think that's it for our logistics. Try not to have that many logistics in each day. Questions? Yes, Tony?
Does it say where you are in your homework? Like if I went in and did a couple tonight and then I was like, okay, I'm tired.
You mean, can you do it a bit at a time? I would love for you to do it a bit at a time and not to wait until Sunday to do the homework. I try to open the homework a week ahead of time, and most of the pre-class quizzes, the only thing that has a smaller window is the post-class quiz.
It'll save everything that you've done.
Yep. Save it bit by bit. Alright. Ready to do another unit conversion problem?
On the app?
Alright. New problem. These shapes have nothing to do with the equalities we had before. This is a totally new problem. Don't try applying what we did before. Just use the process. So I'm going to go ahead and give us about 3 minutes. Remember, set up the problem on paper. What are the equalities? What are we starting with? What are we ending with? What are the equalities? What are the conversion factors? And if you're stuck, please raise your hand, and one of the team will come around and help you. Can we have the team members raise their hands again? Okay, so there's 6 of us here. By the way, feel free to use your neighbors as resources. Feel free to talk this out. This does not need to be by yourself activity.
Okay, so let's get
Would anyone like to volunteer to write their answer out?
Oh, I will.
You've already talked a couple times. I'm trying to figure out who hasn't gotten a chance yet.
I will. I'll do it. Just write it out.
Yep, and the pencil is cool. You can put your hand down and it won't draw.
Okay.
So you can just put your hand down and just write it here. You can write it kind of big because I zoomed in.
Okay.
So try to make it fit.
My husband has one of these, so.
That is really good. Alright. So we have a volunteer without a name tag, and I can't remember her name.
Samantha.
Samantha, who is drawing out her work here. As I mentioned earlier, I'm really focused on the process and not the final answer. So whenever I come around, that's why I really would like to see you trying to write it out using the everything in one, so that I can see whether you're trying to line things up and whether the qualities you're using are right. You put them in conversion factor form. So while she's writing that, can I have a volunteer? What's the first step we do in this problem? New voices. New voices. Thank you. So we identify what our starting quantity is, and so that's going to be 60 squares, and we're going to put that over 1. And what else do we do?
Cancel it out.
Not yet. We have our starting quantity in Crystal.
Where we're trying to get to.
What are we trying to get to? Right? If we don't write that, then we might just have, if you think about it in life in general, we have about 1 billion conversion factors that we can use. I can convert from inches to centimeters, from pounds to kilograms, all these different things. Do I need those? On a regular basis, no, so I'm not going to write them all out. So I want to make sure I identify where I'm trying to go from where I'm starting, so that helps me focus on where I need to go. Okay, so now we have squares, we have arrows that we're going to, and then Samantha, you want to tell us how you filled in everything in between?
Well, it says how many arrows are there for every 60 squares, so I started with 60 squares over 1. And then from there, I had to write everything out because reading it was really hard for me.
Yeah, and that's actually really important to me, that you can take words and you can put them into a mathematical representation. So that is huge, which is what I think we had some earlier people describing, is that we need to take those things that are written and put them in a mathematical format. That's great.
So then from there, I just lined everything up to where it would cancel out until I got to the 3 arrows.
And here's where I'm going to get picky with wording. I'm going to try to stay away from terms that just mean math, and I want to talk about terms that mean something. So mathematically, yes, we are canceling things out. But what is the purpose? Why are we using these conversion factors? What's that?
To convert.
We're using them to convert. So I would look at what Samantha did here, and I'd say, well, this conversion factor looks like it'll let us convert from squares to triangles. Now we have our answer in triangles. Well, I want to then convert from triangles to something else, and I can go from triangles to stars. And then we convert from stars to circles to arrows, and that leads us to our final answer. Units are correct of what we were trying to achieve. I didn't look through this. Does anyone have questions or concerns about the conversion factors she used and when she used them? Questions? Okay, so then we get to a final answer that was 360 over 30. You simplified that, so you said that we have 12 arrows. What's our new equality that we can use as a new conversion factor? Go ahead, Carmen.
60 squares are equal to 12 arrows.
Okay, can we simplify that? How could we simplify that? Is there a mathematical simplification? Yes, go ahead.
You can divide by 12, so 5 squares is equal to 1.
Okay, that's our new equality that we generated out of this. It's a new relationship that we can describe. Feeling any better on this? This process is something I really need to be able to see you doing throughout the entire thing. Dylan?
So also one triangle is equal to one arrow.
Okay, so you could pull out more equalities. And I think this is going back to something that Kisa said earlier. So you can combine individual ones. For the main process, I want to make sure that we're showing everything. But yes, there are going to be other things that we can see equal each other in a nice way as well. One more? All right, and I'm going to close out. It's important that you submit an answer to at least 75% of the questions every day. That will give you credit for participation. So even if you didn't finish it, when we get close to the end, go ahead and submit an answer. I just closed that last one out. But if you have not already done so, womp womp. I think this is in, wait. I lied. This is the same problem, right? This is the same problem. So here is a brand new problem. Remember, once you finish or get an answer, please submit that via the clickers. We'll try to do this in about 3 or 4 minutes. Remember to call us over if you get stuck. Got it? Pointing out in case everyone didn't notice that these are now completely new problems, so some of the equalities might be different from the last problem. if your neighbor is using a similar approach.
Well, yeah, because I completely didn't even use the square at the start. What'd you get at the end? I got 3.
Are they missing a conversion factor?
No,
No? Okay.
they might have more than they need.
I didn't use it.
And that's just.
So as long as we get where we need to be. That's what I was like, so that's gonna change all of
So if you just be able to pull that one,
I'm like, trying to like 8 years.
squishy. All right, we have 41 responses. I'm going to leave the clickers open for another minute. Hi, clicker reef. I don't know, just go for it. So, how are we feeling about pulling out the starting quantity? Let's do a little gauge. We're feeling good about pulling the starting and ending units. Okay, not so good yet. Thumbs up, feeling good. Not so good. Terrible. All right, we're kind of somewhere in between here and here for the most part. So, can I call on Maddie? What is our starting quantity and unit, and what's our ending? Where are we trying to get to?
Our starting's gonna be 8 squares.
All right, so that's our starting, 8 squares. We're going to write that over 1, and then the end, what are we trying to get to? Arrows. Okay, great. How do we get there? Can I have a volunteer who has not talked yet today describe their process? Go ahead, Kiara.
Yeah, so we know that we have, so I multiplied the one triangle over 4 squares.
Why?
Because we have to cancel out the squares.
Okay, so instead of saying cancel out, what are we trying to do with the squares? We're trying to convert from squares to something else. In this case, we can convert to triangles. Okay, great. And then what did you do next?
Then I multiplied 3 arrows over 2 triangles.
Okay, in order to do what? What are we converting from and to?
Converting triangles to arrows.
Fantastic. And then, what do we do next?
Multiply straight across.
Well, we have more conversion factors.
Oh, you gotta cancel out.
So I gave you extra conversion factors. To prove a point that I'm going to give you more than you need, I think that was a question that came up in the last problem. So we want to make sure that all of our, what Kira is saying is right, we want to make sure that we wrote the conversion factors in the right form, top and bottom. So we did mathematically cancel out both squares and triangles. We're left with one unit, which is arrows. So that's fantastic. And we have 24 arrows over 8. Is that right? So that means that we end up with 3 arrows over 1. And if we wanted to, we could say we have a new conversion factors. 8 squares equals 3 arrows. Feeling any better about the approach that I'm forcing you to use? All right, you want to try using it in non-shapes form? Yeah. All right. What I want you to do next is pull out the packet. The packet is unit conversion, the carbon cycle. We are going to focus on Model 1, the first page. Before you start, here is the biggest pitfall of students doing these. We're going to do a lot of these this semester. These are called POGL activities. It's a type of learning material. Read. Read carefully. Most students skip to the question. Almost everything you need is in the text above it. So please, whenever we do these, start at the beginning, read through the text. The second part is that you need to work in groups. This is not an individual thing. So a lot of times it says, everyone in the group, write down an answer, and then talk to each other. So please do that. That social interaction is a way that we construct new knowledge. One more thing to note about it. The beginning of it, it talks about object 1, object 2, object 3. Just to make sure we're all on the same page, it's saying if you took the same object and you put it on 2 different scales or balances to find the weight, this is the numbers that you get. Okay, so object 1 is in both the left and right. Object 2, same. So go ahead and work through the first 5 questions called critical thinking questions. If you have any questions, call one of us over. Talk to the people around you after you've read, and if you have any questions. And we'll check in a little bit. Time is up here.
Unless we just pick one object.
It's just trying to make sure that you can read. For which? Yeah, filling in the table? No, you can go ahead. I don't think it has examples there, right? Two doesn't equal one. Two counts doesn't equal
Ratios describe the rate of each unit's conversion ratio. But that's if you're already.
Question 4 and 5 done the next minute or two. Got to think about you too. Don't get lost on First real test of the hand raise is, can we get everyone back together when they're like really working and focused? So really briefly, did we find any trends in the table? Yeah. Question number 2, can I get a volunteer to raise their hand and describe what trends that we saw? Go ahead, Chris.
So for the first 2 objects, the ratio from pounds to kilograms and kilograms back to pounds were the same. It was 2.2 and 0.4545 continuous. But for the third one, for pounds to kilograms, it was also 2.2, but then it was 45 continuous. So that the third one was slightly different. And then kilograms to pounds, it was 4536.
Okay. So pause for 1 second. So did everyone hear what Chris was saying? That there was almost identical numbers all the way down each column, but not quite. Why? Okay, so there might have been rounding. Why was there rounding?
Because there's only to the hundredth place in kilograms and pounds.
Sig figs only apply in lab, right? We don't care about them here. Okay, so one of the really important things that comes out of this diagram here is that when you use these scales, how certain are the numbers? How do we describe the certainty of them? We describe them all as being certain to the hundredths place. That's what all these are reported as, because that means that that balance is only accurate enough to tell us to the hundredths place. We don't know what the thousandths place of the kilograms or pounds are, either of these. So if I reported an extra 0, if I reported 3.300, I'd be implying that it's a more accurate instrument than it is, and I'm making up stuff. You can't do that. On the other hand, if I reported the mass as 3.3, I'm saying, well, this scale is not very accurate. We only know to the tenths place, and so this data is really not as accurate as we could have known from this. So that is one of the major take-homes I want when you look at this. So because of that, you can report to the hundredths place on all of these. Does that mean that when you divide 2 of these numbers, you're always going to get the same number of sig figs?
You have to write down.
So we have to look at each of these and see how many sig figs are there when we're doing a division process. How many sig figs are in 3.30 when we're doing division? Significant figures. Sorry, using shorthand. That's 3 significant figures when you're doing multiplication and division. What about 7.26? 3 significant figures. So basically what we're saying is the hundredths place is significant, and that's even though it's a 0. What about 9.80? That's 3 significant figures. 21.56. That's 4 significant figures. 0.88. Is it 2 or 3?
No, it's 2.
That first 0 is just telling you like how big it is. It's not an accurate number. So we only have the 2 digits here that tell us about the actual mass of that object. What about this last one here? So then when we're going down and we're doing all the calculations, we say, well, which one is the least precise? And that's the one that limits our sig figs in our answers. So I think that only impacts, so here we're going to limit to 3 sig figs, 3 sig figs, because we had 4 and 3, so the one that's least significant is going to limit that. And then down here in the last one, that means that our final ratio, instead of being 2.20, is going to be 2.2. And then what's the second one going to be then? 0.45. And the other value should be above that should be 0.45. 455. Because you go one past it and then you round. So if we're rounding to 3 sig figs and we have, this is our value that was calculated as the ratio. We say, okay, we're going to go to 3 sig figs. Those are our 3 sig figs. and then we go one past, and we say if it's a 5 or higher, we're going to round that last value up. It's a 5, so that means this equals 0.455.
So you're just saying you convert based on your significant figure?
We're saying that the calculated ratios are going to be based on our significant figures of the measurement that we had. Now, if I'm trying to figure out how much a patient weighs, and I weigh them in pounds, but maybe the drugs I'm giving them lists in this much per kilogram of body weight, am I going to use one of these values to convert? I'm going to go and find a much more accurate version where someone has had much better devices to measure these two values. And so you can look up much more precise conversion factors. But if we're making our own conversion factor, then we're going to have to be limited by the significant figures that we used. So in lab this week and lab next week, I want you thinking about how much precision is there in the instruments that we're using. How do I use that to then actually make calculations? How precise can I say that my final value is? That all depends on the instruments that you're using. So we'll spend more time on that throughout the year, throughout the semester, but that kind of gets us started. All right, the next page, we care a ton about units, but because units are already provided, that's really what question 3 is asking about. It's saying that the units are going to be that ratio, so it just wants to know what the numeric value is. Did anyone figure out the relationship between the two ratios is? 2.20 versus 0.455? What's the relationship between those? I heard someone over here talking about it. I think it's Stephanie.
The connection is going to be with the first one, the pounds to kilograms, you're going to divide pounds from kilograms. Well, in order to get your pound, how many kilograms per pound, basically, is the next one. So if you have 1 pound, you're going to have 0.455 kilograms.
Okay, yes, I agree with your statement, but how can we really clearly and succinctly state how those two values, 2.20 and 0.454545, how are those two related? It's the same number, but
But you multiply to get from kilograms to pounds, you multiply by 2.2.
if you take 1 divided by 2.20, what do we think we're going to get? 0.45454545. Okay, so it is the inverse of each other. Because you're saying, for every 1 pound, that's 0.45 kilograms. Or, if I have 1 kilogram, that's 2.2 pounds. It's saying the same exact ratio, but for one, we're saying if we have 1 of this, how much of the other? If we have 1 of this, how much of the other? So which one of these ratios do we use to convert between kilograms and pounds?
Depends on where you're trying to convert from kilograms to pounds. Or
You can use either one you want, as long as you have the right units on the top and the bottom. So maybe, trying to look at our clock here, we have 5 minutes. I hate that clock, it's like 3 minutes fast. We still have 5 minutes of class left. Let's say that a student weighs 212 pounds. 212 pounds. If we were to convert, if I want to know how many kilograms that person weighs, that student weighs, how would I use the values we just found on the first page? Go ahead and write it down on your paper. Think about the conversion factor approach that we just did. How would we use that? Those conversion factors.
That was a pound.
212 pounds. Shall we do this as a quicker question? Go ahead and click in your answer when you have it.
Oh, it's on the clicker? Okay.
Yeah, Chris. In this case, assume that value is yours. So assume that the weight I gave you is your limiting significant figures. You're not going to see this on your screen because I'm writing on top of stuff. Okay, let's do 30 more seconds. Make sure you're doing this and writing it out in unit conversion form. I want to know what conversion factor you're using. What does it look like? All right, if we're doing this in unit conversion, can I have a volunteer to tell me what we're starting with, what we're ending with, and then what conversion factor we're using? Can I have a new voice, please? Great, thanks.
So we're going from pounds to kilograms.
Okay.
And I did 212 pounds over times 1 kilogram over 2.2.
2.2, and let's just add more sig figs because we know we can look up a more accurate version. Pounds. Is that what everyone did? Did anyone do something different? Cassie, what'd you do?
I started with 12 pounds, and then beside it I did 3.30 kilograms, and under it I did 7.26 pounds. Multiplied across and divided by 7.
Okay, great. Did anyone do a different way? Chris?
I did, I started with 212 pounds and then 0.455 kilograms on top and then 1 pound on the bottom. Oh, 455, not 45.
Okay, which one of these is right? Honestly, any of them is right. Because what we're focused on is the ratio between pounds and kilograms. And all of these have the same ratio of pounds to kilograms because they are the same object measured in both pounds and kilograms. Which one of these is the easiest to put in a sentence? That for every 1 kilogram, there's 2.2 pounds. So this is a conversion factor. It might be easier, we could say this, but for every 1 pound, I know there's 0.454 kilograms. So that allows us to convert from pounds to kilograms. So I don't care which one of these you use. So how many kilograms did we find? 96. Is it 0.46? Sounds like it's 96. 96.4 would be 3 sig figs. And the one part that every single person that gave me that number forgot to say is the unit. Okay? That's the whole point. So what we're going to do at the beginning of next class, and feel free to go ahead and start, go ahead and look at Model 3. I guess class is on Monday, right? So we're going to be spending some time thinking about converting more units with the metric system. You have a homework, you have a pre-class quiz, and you have a post-quiz. So if you don't get started on this, that's fine. We'll be using a little bit of this. Please bring in that class. Maybe get a 3-ring binder because I will be giving out a lot of stuff. If you did fill in the reciprocal interview and want to leave that for me, feel free to leave that now, or you can bring it Monday. You can fill in questions you have for me and answering questions about you. It's a great way for you to learn more about me. Have a good weekend. Make sure to let me know if you have any questions. Yeah, it'd be great. Thank you very much.